Right then, let's talk about electric cars. They're all the rage, aren't they? Silent, quick, and full of clever tech. But what makes them go? It's not just a big battery and an electric motor. There's a secret ingredient, a little box of tricks that acts as the motor's own personal brain. This brilliant bit of kit is called the Motor Control Unit, or MCU for short. Think of it like a translator and a drill sergeant all rolled into one. It takes your simple command, "Go faster," and turns it into a precisely controlled symphony of electrical power that makes the wheels spin. Without it, the motor would be a useless lump of metal and wires. Now, you might think the main computer, the Vehicle Control Unit, or VCU, does all the thinking. And it does, but it's the big boss, the CEO, sitting in the corner office. The VCU decides the overall strategy, like we need to accelerate now. But it doesn't get its hands dirty with the nitty-gritty details. It delegates that job to the specialist, the MCU. The MCU is the middle manager that understands the very specific language of the electric motor. It's the crucial link that translates the driver's wishes, sent from the VCU, into the exact electrical signals the motor needs to perform its duties flawlessly, from a gentle crawl to a full-on pin-you-to-your-seat launch. So, why is this so important? Well, an electric motor isn't like a simple light bulb you just switch on or off. It needs a very specific diet of electricity to work properly. The battery in an EV stores power as direct current, or DC, like a normal battery. But most powerful EV motors run on alternating current, or AC, which is far more efficient and controllable. The MCU's most fundamental job is to perform this electrical alchemy. It takes that steady stream of DC power from the massive battery pack and expertly chops it up, shapes it, and turns it into the perfect three-phase AC power the motor craves. It's a genius piece of engineering. This little box is the unsung hero of the electric revolution. It's not just about making the car move. It's about making it move well. It dictates how smoothly the car accelerates, how efficiently it uses its precious battery juice, and how it responds to every single input from your right foot. It ensures the motor doesn't overheat, spin itself to bits, or do anything else naughty. Every time you marvel at the instant torque of an EV, you're really experiencing the handiwork of a brilliantly programmed MCU. It's the difference between a jerky, uncontrollable science experiment and a polished, exhilarating driving machine. A very, very important job, you'll agree. Let's dive under the bonnet, metaphorically speaking, and look at what the MCU actually does all day. Its main job, as we've said, is power conversion. Inside the MCU is a critical component called an inverter. This is where the magic happens. The inverter is packed with powerful, fast-acting switches, usually things called insulated gate bipolar transistors, or IGBTs. These are like ridiculously fast light switches that can flick on and off thousands of times per second. By controlling the timing of these switches with incredible precision, the MCU can create a smooth, flowing AC wave from the battery's flat DC power, essentially tricking the motor into thinking it's plugged into the mains. Once it's got the right kind of power, the MCU then needs to control the motor's speed and torque. When you press the accelerator, you're not actually connected to the motor. You're sending a signal to the MCU that says, "More power, please." The MCU interprets this signal and adjusts the AC power it's sending. To make the motor spin faster, it increases the frequency of the AC waves. To give you more grunt or torque for climbing a hill or a blistering overtake, it increases the amplitude or the voltage of those waves. This is all done using a clever technique called field-oriented control, or FOC, which allows for incredibly precise and independent control over both speed and torque. Of course, a car needs to go backwards as well as forwards. This is another one of the MCU's party tricks, and it's brilliantly simple. An AC motor's direction of rotation depends on the sequence of the 3 electrical phases it receives. To make the car go in reverse, the MCU doesn't need a complicated gearbox with extra cogs. It simply swaps the sequence of 2 of the 3 AC power phases it's sending to the motor. Instantly, the magnetic field inside the motor starts spinning the other way, and voila, you're reversing. It's an elegant and efficient solution that showcases the beauty of electric propulsion. Beyond just making the car move, the MCU is also the motor's bodyguard. Electric motors can get very hot, especially when you're driving them hard. The MCU constantly monitors the motor's temperature using sensors. If things get a bit too toasty, it will intelligently reduce the power output to protect the motor from damage. A bit like a race engineer telling a driver to cool the engine. It also watches for electrical faults or other dangerous conditions. If it detects a problem, It can shut the power down in a fraction of a second, ensuring the safety of the vehicle and its occupants. It's a guardian angel made of silicon and copper. An EV is a bit like a highly trained special forces team. Each system has a specialized role, but they must communicate perfectly to complete the mission. The MCU is a key team player, constantly talking to other vital components. Its most important relationship is with the Vehicle Control Unit, or VCU, the car's central computer. The VCU is the commander. It takes inputs from you, the accelerator, the brake pedal, the gear selector, and decides what the car should do. It then sends these commands to the MCU over a high-speed communication network, typically a CAN bus or controller area network. The MCU receives these orders and executes them with precision. Another critical conversation happens with the Battery Management System, or BMS. The BMS is the watchful warden of the battery pack. It knows everything about the battery, its state of charge, its temperature, and its overall health. The MCU is constantly asking the BMS, how much power can I safely draw right now? The BMS replies with the exact limits. If the battery is cold or nearly empty, the BMS will tell the MCU to limit power draw to protect the battery cells. This constant dialogue ensures that the powertrain operates within the safe limits of its energy source, maximizing both performance and battery lifespan. It's a partnership that's essential for a healthy EV. The MCU also listens intently to the motor itself. Many MCUs use sensors like resolvers or encoders attached to the motor's shaft. These sensors tell the MCU the exact position and speed of the motor's rotor at all times. This feedback is crucial for sophisticated control strategies like FOC, allowing the MCU to apply power at the perfect moment for maximum efficiency and smoothness. Some newer, even cleverer systems are sensorless, where the MCU analyzes the electrical signals returning from the motor to figure out its speed and position without needing a physical sensor. This makes the system simpler, cheaper, and more robust. This network of communication is what makes an EV feel so integrated and responsive. When you press the brake pedal, for instance, the VCU might decide to use regenerative braking. It tells the MCU to reverse its function. The MCU then changes the electrical fields in the motor, turning it into a generator. The resistance from this process slows the car down, and the MCU sends the captured energy back towards the battery after a quick chat with the BMS to make sure it's okay to send power that way. This seamless coordination between the VCU, BMS, and MCU is what makes advanced features like one-pedal driving possible. So how does all this technology feel on the road? Let's look at a few driving situations. You're sitting at a green light. You press the accelerator. The VCU sends a go-for-it signal to the MCU. The MCU instantly checks with the BMS for available power, then unleashes a torrent of perfectly formed AC current into the motor. The result is that famous, instant electric torque. There's no waiting for an engine to build revs or a turbo to spool up. The MCU delivers maximum pulling power from a standstill, pushing you back in your seat with a silent, continuous surge of acceleration. It's a smooth, seamless, and utterly addictive experience. Now imagine you're heading down a steep hill. In an old petrol car, you'd be riding the brakes, turning that energy into useless, smelly heat. In an EV, the moment you lift off the accelerator, the VCU tells the MCU to initiate regenerative braking. The MCU flips its role, turning the motor into a generator. It uses the car's own momentum to create electricity, which it then sends back to the battery. This not only slows the car down in a controlled way, reducing wear on your brake pads, but it also recaptures energy, slightly increasing your range. It's a beautifully efficient process, managed entirely by the MCU. What about a tricky situation, like starting on a steep incline? The MCU's precise control is your best friend here. It can apply just the right amount of torque to hold the car perfectly still without any rollback. When you want to move forward, it smoothly feeds in power, preventing the wheels from spinning while delivering enough grunt to pull you up the hill effortlessly. This level of fine control is something traditional internal combustion engines struggle with. The MCU acts like a built-in, super-intelligent hill start assist, making difficult maneuvers feel astonishingly easy and secure. Ultimately, the benefits of a sophisticated MCU are clear. It is the secret to a brilliant electric car. It delivers that signature smoothness in power delivery, eliminating the jerks and vibrations of a fossil-fueled engine. It is the key to efficiency, carefully managing every electron to squeeze the maximum possible range from the battery and recapturing energy that would otherwise be wasted. And finally, it provides vital protection, constantly monitoring the heart of the car, the motor, to ensure it operates safely and reliably for years to come. So next time you enjoy a silent, powerful drive in an EV, give a little nod of appreciation to the clever box doing all the hard work, the magnificent MCU.